Hello everyone, my name is Simeon. I'm integration lead for Neon EVM. So before starting with what is Neon EVM, I want to see with who I'm dealing here. So how many of you guys are tech people, like developers, software engineers? Okay. And how many of you are BD, marketing, and other relations with? Okay. So yeah, we got a lot of reg builders trying to deploy on Ethereum, right? When there are high gas fees. So yeah. Okay, so yeah, today I will tell you what is Neon EVM and how do we aim to combine the best of the Ethereum virtual machine with the scalability of Solana. And yeah, you know, when you hear EVM and Solana into one sentence, it's for tech people, it's really strange because they're completely two different monsters, as I can say. But yeah, so basically in essence, Neon EVM is actually a smart contract in Solana that can execute EVM bytecode. And it's not only that, but Neon EVM as a whole, as an abstraction layer, it brings the best of both worlds. So builders can easily deploy their EVM bytecode on Solana using Neon EVM with any language or any compiler that can compile from one language to EVM bytecode. For now, we know Solidity and Viper, but maybe in the future, I believe there are going to be more and more languages for EVM. They can use their well-known tools like MetaMask, Hardhat, Truffle, Remix, and also we provide a full Ethereum RPC compatibility. And from the other side, we inherit because we live in Solana. We are not an L2. We don't have a separate network. We don't roll up. We're not a roll up. We're something between layer 2 and layer 1. I would say layer 1.5. And we inherit some of the, I would say, features of Solana, like parallel execution, low gas fees, high transaction speed. Our transaction settlement is 1.2 seconds on Neon EVM, and those are around three blocks. And yeah, so let's see what is our infrastructure, because only having the EVM inside Solana, like a smart contract, is not really enough to provide a seamless experience. So we have the EVM, as I mentioned, we have the so-called proxy server. We're going to talk a little bit later. Actually, I think in the next slide, after 2 slides. The proxy server is our RPC. We have a fully compatible Ethereum Tracer API helping to trace, debug transactions, and also our block explorers are using this Tracer API in order to show users internal transactions and everything that you can see, for example, on Etherscan or yeah. We have Neon Pass, which is our native bridge from Solana to Neon EVM. And as I mentioned, there are no lockings and there are no intermediaries because we aim to be fully interoperable with Solana. We have the Neon Faucet, which is like a faucet for our DevNet and our testnet, and it's really generous, so you can get 100 neons at a time. And we have the Neon DAO. Actually, the Neon DAO is the owner of the Neon EVM smart contract. So any change to Neon EVM inside Solana is governed by Neon DAO. And yeah, we have really low transaction fees, and we can scale up to 2,000 transactions per second. So currently we are around, we've done a lot of performance tests and we're around 1,000, but we will soon get to 2,000 transactions per second. It's on our roadmap. This is our ecosystem. As you can see, we support mainly and only EVM, dApps, and let's say wallets. We support Ledger. Soon we will support Ledger Live. We support Safe, bridges, as I mentioned, Neon Pass. We actually announced partnership with the bridge recently. So we are going to have a good cross-chain bridge. We also have Covalent and the Graph as indexers and 2 blockchain explorers. You can see that we have a vertical Solana, and this is very interesting because, as I mentioned to you, Neon EVM is a smart contract in Solana. So in theory, we can natively call and interact with Solana programs, and our current use cases for native interaction is that you can deploy an ERC20 in Neon EVM, which is actually an SPL token in Solana, so you can use Solana liquidity in our EVM. So let's say you want to create a fork or your own protocol, let's say Uniswap V2 fork. You can deploy a pool with SPL tokens on our chain. And we also read natively Chainlink price feeds from Solana, and the same with Pyth. And yeah, that's why, and we aim to provide general interoperability with Solana. And also in terms of IDs and tooling for developers, we support the latest, Hardhat, Foundry. Foundry is really, I would say, nice tool to use, and I personally use it. And yeah, that's pretty much our ecosystem. Apart from dev tooling, this is a more, you can see a more verbose diagram. And we support all SDKs and APIs for EVM chains. So let's go back and see how do we achieve this seamless experience, and how do we aim to provide for the users a seamless EVM experience, but we are on Solana. So as you can see, Neon EVM is actually the smart contract on Solana that can understand EVM bytecode and can execute this EVM bytecode inside Solana virtual machine. But one of the most important aspects, and I would say services that we support, is our Neon proxy. So Neon proxy is our so-called public RPC, which actually from the user side accepts Ethereum-like transactions. It unwraps the Ethereum transactions, creates a Solana transaction, and submits it to Solana node with like an entry point, our Neon EVM program. And why is that? That's because Solana is very different. We can see how, so the first most important difference is that Solana is stateless. Solana is not a state machine. So how does Solana handle state? You can imagine Solana as being a big file system where you have only 2 types of files, and in Solana there are accounts. So we have program accounts, Solana program, and we have data accounts. And data accounts are like TXT files, and the programs are like executable files. So each program, in order to maintain their state and to have a persistent state, they create program-derived accounts and store their data in those accounts. And this is this architecture choice is, we can talk a lot about it, but this architecture choice is made in purpose because Solana actually supports parallel execution because of that. And in the context of Neon EVM, it's the same. So Neon EVM is actually the abstraction layer, and Neon EVM has the bytecode of the execution layer of Ethereum. And as you can see, for example, the account up there is actually an externally owned account that Neon EVM creates for the user, and inside the data, it stores the Ethereum address, nonce, balance, and so on. And it's the same with contracts and so on. So if we go back to this photo, to this diagram, you can see that if a user wants to transfer 10 Neon, he will commit the same Ethereum-like transaction, but Neon EVM will actually read this bytecode and to actually deduct the balance from it will actually edit the data, the metadata for the 2 Solana data accounts for the user. Yeah, it's actually this one, yeah. And let's see how a Solana transaction looks like, because it's really, really important to know that the composition of Solana transaction and Ethereum transaction is really, really different. And one of the most important things is the account list. So the account list contains all of the accounts, all of the data accounts that are going to be read or written to in this transaction. And this is one of the main reasons Solana supports parallel execution. And we will have all the accounts that are going to be modified or read into. We're going to have the program index. In our case, it will be the Neon EVM account index. And we also have some data. And the data is like the Ethereum-like, the data that is regarding this Ethereum-like transaction that will be used from the Neon EVM. And as you can see, this is a diagram explaining a little bit how parallel execution works. So let's say we have a couple of transactions, Solana transactions that will interact with Neon EVM program. So actually, the Solana node actually will check this account list. So if we have 2 transactions that have different account lists, so they're going to read and write from different accounts, that means that those transactions can be executed in parallel. And this is actually a very good feature, I would say, because I think I read a tweet 2 weeks ago and saying that currently the Ethereum state is like that. You want to order an Uber in your hometown, but you pay not $20, but $120 because there's a concert in the capital. So global gas fees are something that has to be dealt with. And this is how Solana deals. And one of the main features of Solana is local gas market. So basically, gas prices go up only for the most used dApp, not for the other dApps. So doesn't matter if like DGen NFT collection is really trendy right now, you can still stake or unstake your tokens into another protocol. So what's incoming for Neon? The most important part right now for Neon is users to be able to bridge assets from other EVMs. So currently we support only Neon Pass that offers seamless bridging between Solana and Neon EVM. But let's be honest, like most of the liquidity is on other EVMs, and we want to provide users with a seamless experience. So the bridge is going to be our cross-messaging layer, and people are not going to be able only to bring assets into Neon EVM. They're going to be able to use the bridge cross-chain swapping with no slippage and actually no liquidity pools. And also, they are going to be able to implement their cross-chain messaging. For example, if you want to deploy Neon and you have a cross-chain, let's say, governance, you will be able to do it with the bridge. And the bridge is actually pretty nice because it's completely decentralized, so anyone can execute the transaction on the destination chain if it is approved by their keepers. Another feature is, really important feature, is gas payments. So with Neon EVM, you'll be able to pay for your gas with any token you have. And it doesn't matter if it's Solana, Neon, or USDC or USDT. This feature is actually currently on testnet. I think I'll be able to show it to you now. So yeah, in essence, this is this feature. You'll be able to pay in any tokens. We plan to support at least 5 tokens like USDC, USDT, Solana, and Neon, and add some more tokens later. And the last, and I would say the most difficult part, will be to have a composability and full interoperability with Solana. So currently we have our main use case is support SPL tokens in Neon EVM. Our next goal is to support Solana NFTs. And our main goal is to support any protocol or any program from Solana to be able to be called from Neon EVM. So let me try and show you fast how this works, the gas payments with any token. So we implemented for each token that you want to use. Let's say right now we want to pay with Solana. You're going to have a different RPC that will basically show your Solana balance. So for testnet right now, we have 2 RPCs that are basically the same network, that are basically non-testnet. But on this RPC, you can see this is my Neon balance, and on this RPC, this is my Solana balance. So let's say if we want to transfer some Solana from one account to the other, hopefully testnet works. And yeah, we'll be able to do it. Yeah, as you can see, it's confirmed. Our balance is deducted, and here our balance is accrued. Also, let's say if we have a token, because with a token I can show you that also on the other chain, I mean on the other chain in quotes, that this token is also transferred, that they're the same chain. So let's use Neon right now and transfer to account 5 0.5 tokens. So yeah, it will take some time. Actually, an interesting thing about MetaMask is MetaMask has hard-coded 6 seconds to check if the transaction is still pending. So a lot of times the transaction was actually verified and settled down. So yeah, so here you can see we have 0.2, and if we switch, you can see that we still have 0.2. So we are on the same network, we just change our payment. We just change our gas token. So this was my fast demo, and that's actually it. I'll be around, so if you guys have any questions, I'll be happy to answer you now. Yeah.
So one thing that you mentioned is that you actually store Ethereum state, like your Neon EVM state, in multiple Solana files. How do you know which of them will be accessed by a given contract when it's about to be executed?
Yes. So I can show you this slide, and yes. So we perform simulation of the transaction in the proxy.
Right, but the simulation might have completely different results.
No, simulation is deterministic, because the simulation will have, we don't care about the results, we care about which accounts we are going to modify.
Right, but if my contract, for example, touches different results depending on the current block time,
yeah,
then when you actually execute in Solana, it will be a different block time, no?
No, it's going to be, so the Neon proxy, it has connections with Solana, so it actually knows which, with block time is a little bit different. You gave the exact edge case that we currently, that's our only thing that we didn't support it yet, using block timestamp and block number in our mapping as a mapping key. because basically this relies on exactly on which account you are going to store it, because you use like a KESAC of the slot and so on. So that's actually one edge case, but I'm not sure. I think that currently on DevNet we have this fixed. So I'm not really sure exactly how it's fixed. I'm not really sure of the developer, specifics. But yeah, that's the only thing that is hard to achieve. Yeah. Any other questions? I guess no. Okay. Thank you very much, guys. Hope you enjoyed it, and yeah, I'll be around.